This is the solution to example 7 from note 6.2. And in this problem, we're given a triangle with partial information, and we want to find an unknown acute angle. And we're given a right triangle here. So we can see the setup. We are trying to find the acute angle, which is labeled theta. So that's this angle here. And we're given the lengths of two sides. So when starting a problem like this, I would label the side lengths relative to the angle that we're interested in. So relative to theta, I would angle the side opposite. So if we go across the triangle, that side is going to be the opposite side. So I'm going to write that in. The side across the triangle, or opposite from the right angle, is the hypotenuse. And then the remaining side is the adjacent side. So we're going to use right triangle trig here to find the missing angle, theta. So we know that we were given the length of the adjacent side and the length of hypotenuse. So if we think about SOHCAHTOA, we're given the adjacent side length and the hypotenuse, which means that we want to use cosine just because of the side lengths that are given. So we'll say that cosine of theta is the length of the adjacent side over the length of the hypotenuse. The length of the adjacent side is 11. The length of the hypotenuse is 21. And now, in order to find the measure of the angle, we can use the inverse trig function. And typically, we don't bother writing cosine inverse of cosine theta equals cosine inverse of 11 over 21. We'll just skip a step and we'll say theta is equal to cosine inverse of 11 over 21. And if we enter that in our calculator and we're in degree mode, we'll find that theta is 58.4 degrees.